Hey guys, hope you're having a good weekend. Let's get this video going, and we'll see you on Monday. Make sure we get these notes and pay attention and get everything down. Let's start off here at the top. It's something we're recalling, so this is information that we've seen before. And it asks what is the point and what is the slope, and it gives you the equation in point-slope form. Again, that's y1, it's x1, and there's your slope. So your slope, we can tell right now, is 5. Your point, your parentheses, your x-coordinate is 20. And your y-coordinate is 30. Again, that's pretty bad. You can tell, 20 and 30. Okay, the table, just reading what it says here. The table shows the world's population growing at a rapid rate. Identify the independent variable. Okay, the independent variable. The independent variable is your x, so that would be the year. And your dependent variable would be it's the only other one there. Your dependent variable is the population. You think about it, the population depends on the year. Okay, to the right there's a scatter plot, so it shows all this graph right here. All this graph right here is showing you the points. It's showing these points right here. It's just graphing them. It's a scatter plot. Okay? And you can also tell right now you got a line of best fit. What relationship exists, if any? If you can see that line of best fit right there, that has a positive correlation. Y'all remember talking about this before. Again, positive correlation. Yeah, it's the line of best fit. Just realize that is a positive line. That's a positive correlation. Okay, now this is what's new. We're going to write the slope-intercept form for the line of best fit. We've found equations for the line for lines with point slope and turning that into slope-intercept. And the only thing new is now we're doing for lines of best fit from a scatter plot. So let's look right here and see what it says. The line of best fit passes through, and it gives us 2 points. Okay, so there's x1, there's y1, x2, y2. All right, and it says find the slope. How do we find the slope? That's our slope formula. y2 minus y1 over x2 minus x1. Our y2 is 5,900 minus our y1 is 1,000. Okay, put that over x2 1998 minus 1850. Okay, so what that equals, using the calculator, that's going to equal 4,900 over 148, which if you type that in a calculator, that equals 33.1. Okay, so we found our slope. Step 2, okay, use the slope of the m, which is 30, we just found that, 33.1, and the point slope to write the equation. Okay, so again, point slope, y minus y1 equals m times x minus x1. All right, so let's rewrite this using the information we have. We have 2 points. You have a point here and a point here. You can choose either one, so just pick one. Let's just use this first one. Let's use this point right here. So what we're going to do, we're going to say y minus, our y1 is the y-coordinate, that is 1,000. So y minus 1,000 equals the slope, which we said was 33.1, times x minus the x1 coordinate. Again, to go back, look at our point. The x1 would be 1850. There we go. Okay, so there's our equation in point slope, which is what it asks us to do. If it asks us to find slope-intercept, if we want to know slope-intercept form, we would distribute. So I'll do this one in blue. Okay, slope-intercept. Slope-intercept, I would distribute. If it helps to draw the arrows, then draw the arrows. So if I did that, I would have 33.1x minus 33.1 times 1,850 would be 61,235. No, I did not just do that on the top of my head. I plugged it in the calculator, which I expect you to do the same thing. Okay, so now we have y minus 1,000. I'm just copying that back down. Equals 33.x minus 61,235. So now we want to get y by itself. So we're going to add 1,000. Okay. Again, if you want to draw your line down the equal side, so we add 1,000. Over here, these cancel. So all I got left is y equals 33.1x minus, and again we had 61,235 negative. It's a negative. We added 1,000, so what we have left is 60,235. There's your equation in slope-intercept form, if that's what it asks you to find. Next page, we use the equation of line of best fit to predict. Again, lines of best fit, that's what you can use to predict. Okay, using the equation of line of best fit, predict the population in millions for the year 2012. If you go back to the previous page there, our equation was y equals 33.1x minus 60,235. That was on the last page we just did. Okay, now let's see what it asks us to do. It asks us to predict the population in millions. It gives us the year. In our equation, X represents the year. So let's plug 2012. Let's plug that in for X. So we would have Y equals 33.1 times 2012. Okay, minus 60,235. So we use the calculator. So y is going to equal 33.1 times 2012 minus 60,235. And if you use your calculator right there, you can that turns out to be 6,362.2. And if you look back at the equation, this is in millions. And it tells you in parentheses right here, in millions. So this is millions. I know this is terrible handwriting, but you can see it. Okay, the last one, using the same equation. So we're going to use the same equation. If you want to write, write it down again. Y equals 33.1x minus 60,235. All right, to predict the year. So we want to predict the year when the population is 6,115.5. Okay, so now it gave us the population. If you look back in the equation, you look back at your table, you can see that that population is the y value. So I'm going to take that number and I'm going to plug it right there for y. So I got 6,115.5 equals 33.1x minus 60,235. Okay, now again, you can use your calculator. You need to add 60,235 to both sides. So you can plus 60,235. These cancel. Okay, there's your equal signs. So those cancel. All you have left is 33.1x equals, and if you add these together, if you add them together, you can see real quick. Let me type it in. 6,115.5 plus 60,235. What that would equal is 66,350.5. Last step, divide by 33.1. Divide by 33.1. If you do that, your answer ends up being x equals 2004.5. So you could say in the year 2004, or if you round up, really you're closer to 2005. Okay. All right, those are the notes. We'll talk about these tomorrow. Hope you have a good weekend.